You know, we're surrounded by buildings every single day. But have you ever stopped to think about the invisible war that's happening inside every single one? It's this constant battle against gravity, against the building's own just immense weight. So how in the world do these giants stay standing?
Now, really, think about it for a second. Forget the furniture, forget the people. I'm talking about the actual concrete, the bricks, the steel. What does it all add up to? 1,000 tons? 10,000? It's a question that feels almost impossible to answer, right? But for an engineer, it's the most important question there is.
At the very heart of this whole challenge is a concept with a simple and, honestly, a kind of grim name, dead load. And this isn't just some technical jargon. It is the fundamental problem that every single structure has to solve, from the moment it's built to the day it's torn down.
So what is dead load? Well, it's basically everything that's a permanent part of the building. It's not just the skeleton, the concrete floors, the steel beams, the brick walls. It's every single permanent fixture, all the plumbing, the electrical conduits, even the plaster on the walls. It is the weight that never, ever goes away.
And this is where the stakes get incredibly high. I mean, think about it. If you underestimate the dead load, the structure is unsafe. It could risk collapse. But if you overestimate it, you're just wasting materials, driving up the costs, and really limiting what you can do with the design. So the million-dollar question is, how do engineers get this number exactly right?
Oh, here's the secret. Engineers do not guess. They can't. They rely on these incredibly detailed guides. And in India, for example, their Bible for this is a document called Indian Standard 875 Part 1. You can think of it as the official encyclopedia of how much stuff weighs.
This document, published by the Bureau of Indian Standards, is the single source of truth. Inside, you find these meticulously compiled tables with the unit weights of hundreds and hundreds of materials. It makes sure that every engineer in the entire country is working from the exact same playbook.
And this is no dusty old book either. It's constantly evolving. It was first published way back in 1957, and it's been revised over and over again to include everything from new research on wind pressure to switching over to the metric system. Part 1, the one we're talking about, is just for dead loads. Other parts cover wind, snow, even earthquake forces. And the next big revision is set for 2026, to bring in all the latest materials that are shaping our modern world.
Okay, so how does an engineer actually use this standard to figure out the dead load of a building? Well, they basically deconstruct the entire building, but on paper, weighing it piece by meticulous piece. Let's break down how that works.
Let's start from the ground up, concrete. Now, you might think concrete is just concrete, right? But the standard is so much more specific. Simple, plain concrete is heavy, yeah, but add just 2% steel for reinforcement and you can see the weight just ticks up. And then you've got modern stuff like lightweight cellular concrete, which is dramatically lighter. Each one has its own precise weight range.
Let's just zero in on that number for reinforced concrete for a second, just so we can feel the impact. 24 kilonewtons per cubic meter. What does that even mean in the real world? Well, it means a box of this stuff, just 1 meter by 1 meter by 1 meter, weighs around 2,400 kilograms. That's more than an average car.
Okay, so let's move up to the walls. And it's the same incredible level of detail here. A standard brick wall has a totally different weight than a concrete block wall. And what about natural stone? Granite is one of the heaviest materials an architect could possibly choose. Look at that, it weighs even more than the reinforced concrete we just talked about.
And this really gets to the heart of the whole philosophy of the standard. There are no assumptions. There's no guesswork. The dead load calculation is this super meticulous accounting exercise. You're adding up the weight of every single component to get a perfectly accurate total for the whole building.
But here's where it gets really, really cool. The standard goes way beyond the obvious stuff like bricks and concrete. It forces engineers to think about things you would never, ever guess are part of a building's permanent weight.
Take green roofs, for example, super popular in modern buildings. Well, that garden on your roof, that's a dead load. The soil, the drainage layers, the walkways, it all counts. And here's the crucial detail. Engineers have to calculate the weight using fully saturated soil. They have to plan for the absolute heaviest it could possibly be, like right after a massive downpour. It's a core principle. You always plan for the heaviest possible version of reality.
The standard even has this massive table just for stored materials, for when you're designing a warehouse or a silo. And the level of detail is it's fantastic. It lists everything from coffee and butter to molasses and hay. Can you just picture an engineer deep in their calculations having to look up the official unit weight of loose hay? It happens every single day.
So, a fun list of weights is one thing. But this all comes back to a very, very serious purpose. This standard isn't just some academic exercise. It is the absolute bedrock of both structural safety and construction efficiency.
It's really this incredible balancing act between two big goals, safety and efficiency. On the one hand, you have to calculate the absolute maximum load to make sure the building will never fail. But on the other hand, you have to calculate it precisely to avoid over-engineering, using way too much concrete or steel, which is wasteful, expensive, and ultimately it stifles creativity. That precision is what allows architects to design soaring atriums and daring cantilevers. It's not just about saving money, it's what enables great architecture.
And you don't have to take my word for it. The foreword to the standard itself says it best. The goal is to, quote, not only ensure the structural safety of the buildings, but also eliminate the waste caused by assuming unnecessary heavy loadings. This one document protects both our lives and our resources. It's the silent hero behind every safe and efficient building.
So the next time you walk into a building, just take a second. Think about that hidden weight, that incredible, constant force, and the unbelievably detailed calculations that keep it all standing strong. It really makes you wonder, doesn't it? As we innovate with things like 3D printed structures and ultralight composites, what new, amazing things will be added to this essential book of weights? What will the buildings of tomorrow truly weigh?